Hi, good evening everyone. I am Swami and he's my colleague Karan. We are working as SDET at InMobi. The problem that we actually tried solving at InMobi was, so as and when this, so we could see that there is a huge improvement with respect to the Hadoop technologies and the big data technologies. But when it comes to testing all these technologies, so we always have something challenging and we felt that that needs to be overcome technologically. So that is where we started working on how we would basically bridge all these gaps with respect to the problems that we face and try to effectively improve the time to release for the production. So So the automation framework that we had actually designed, so we named it as Strider. So before getting into the details, I would try to explain more about what are all the key takeaways of this presentation. So the first thing is Strider is built on top of Falcon APIs, Uzi, and Hadoop. So by the way, who are all do people know about Falcons and who is comfortable with Falcon? Can Okay, okay. So I would explain more about Falcon in the forthcoming APIs, at least a brief description about it so that you could feel comfortable. And Strider is using Strider, doing a sanity testing, the functional and the regression testing is possible. It also helps you in bootstrapping the hosts. That is, which means that before I want to run a test, I want to make the host test ready. So that is being possible. The framework basically takes care of it. And next is the data type handling using JSON, which means that sometimes like when we see for the Hadoop jobs, we will get to have a lot of inputs, and these inputs may be of different data types, and it may be spitting out a lot of output which may be of diverse data types. So the framework can do the data handling part, which can understand a common data for itself. It should be able to convert and reconvert any data from the input level to the output level. And so the other good parts are like it is pretty easy to create the test and it is extensible. So the extensibility part is with respect to different levels, which would be explained later in the forthcoming slides. So to start with, like, what do we actually do? InMobi basically serves ads to the say everyone will be using the smartphones. So when you are using an app, so you will be served an ad. So that ad could most probably a targeted ad, which means that somebody wants to invest money on InMobi to say that some targeted ads needs to go to the user, and InMobi knows the way to find out the right user and serve the ad accordingly. So this is the key point here is the system should understand how what the users are. It should have a good understanding towards the users, and I should target the ad specifically to the proper user for the better return of investment. So in order to do that, we need a huge amount of data to be present, and we need to know how to process and how to get the data appropriately. So just to explain the volume of content that we have, so we kind of handle close to 1 billion users, and we are able to crunch close to 5 terabytes of data per day, and it is growing in a very faster rate. And the moment we talk about the data, so once we have all the data being present, we need to orchestrate it in such a level that I can basically design an efficient pipeline which could be easily managed. So for that purpose, we had used Apache Falcon. So now to tell more about Apache Falcon, Apache Falcon is a feed and a data processing platform, to tell it in a simple way. So what does it mean? So it means that any Hadoop job must need an input. So which could be a HDFS path, data present in a HDFS path or something. And I'll be having some Hadoop jobs. It will be processing towards the data and it will be giving me some kind of outputs. So Apache Falcon is more of how do I orchestrate it in a manner such that I could manage my pipeline well. So as I said, it's a data processing, which means that there is a process involved, and you can safely assume that that process is nothing but a collection of one or more Hadoop jobs, and I would be having something called as a feed, which would be nothing but a Hadoop path that contains my input data. So and whatever output that is being spewed by the process can also be assumed as a feed. So apart from that, it is also much more helpful in replication of data and scheduling data according for in a specific timeline. So all these things, Falcon uses Uzi for all those scheduling aspects, which in turn uses Hadoop for spawning the jobs. let me say what, as a tester, we started facing after all this orchestration and designing of pipelines. So, an example, so I could say this as an example of a pipeline where I would say, okay, so I have a process where I have a couple of feeds which is going to give me an output. So similarly, there is a process 2 which contains feed 4 and feed 5 which is going to give me a feed 6, and there is a process 3 which is going to process the other two, the above two feeds, and give me a feed 7. So this is in from a business perspective, this is more like, I have three process which is going to process me the data, give me an output which makes a logical meaning from the business perspective. So so we call those logical block as a pipeline. So the moment we say about pipeline, what are all the typical scenarios that we face that needs to be tested before it goes to the production? It would be an addition of pipeline which would directly impact an input data and also the processing logic. And the next thing I could say is a deletion of a pipeline which could actually impact the things at the same level. And I mean, deletion of process and the addition of process. And apart from that, it is not just in the process level, it is also in the feed level. That is, my feeds may reduce, my feeds may increase. And like, these are all something that may happen on a volatile manner based on the requirements that change in an internet company. And there may also be a lot of scenario where the data that I consume may have a different schema yesterday, and it may have a different schema tomorrow. So having all these things in mind, what do a tester needs to do? What kind of problems we face, and how do we try to tackle that? This was the main problem. This was the main thing that we were focusing on. Okay, so from the tester's perspective, when a developer develops and he is giving me a build, so these are all the following steps that we tend to do in order to make sure that the build is has a good quality, it is production ready, and it can go for the deployment. So some of the things that we do is like, it starts from validating the distribution. So distribution is nothing but when somebody is giving me a Falcon process or a Falcon feed process or a feed XML, how do they basically want it to be deployed? What is the deployment unit? It can be as simple as a tar file or a gunzip file, but in InMobi we try to follow the Debian format. We try to install that and using a Debian and work on that. So as soon as we do a sample sanity testing on top of all these distributions, we try to create some of the input data for testing a specific functionality. So one of the major challenges that we face here is we have totally close to 20 plus types of custom input data and output data. So it may even increase tomorrow. So given such a volatility and such a level of breadth, creating an input data is not a very straightforward manner. And the next part was the validation. Similarly, when the output part, the output data type is pretty diverse, so naturally I face the same problem as that of what I face for the input data. And the next part is the host setup. Almost a lot of companies would have some kind of resource constraint, like, we may be using a host yesterday, but tomorrow we may be getting assigned to a different host for testing. So in that case, doing something manually and going and updating a host manually is a very cumbersome thing. So can a framework do something about it? So we were able to address that. And the next part was the regression. So once the functional test was completely covered and once the bugs were being fixed, and when it comes back to the QA for testing once again, how soon can we able to run the regression test? That was one of the main challenges that we had faced given the volatility of the overall problems. And the next part was, once we decide that everything is functionally ready and all I need to do is some kind of sanity of the overall pipeline, I give some kind of random data, I just make sure that the pipeline is safe, it doesn't crash anywhere. So just by giving some sample random data and production data. So that is one of the part that we were able to focus. And next part is the parallelization and some end-to-end test with respect to the pipelines, and making it continuously integrated. So how did we actually approach it with respect to the previous pre-strider way? So in the pre-strider way, we just had some disjoint script. We were able to do some kind of validation, just download the distribution, validate whether whatever structure you wanted to provide is sane or not, do check whether the XML is fine or not, those kind of basic validation we just tried doing. And after that, when things were in a very premature way, when we wanted to insert the individual test data. So what happened was, since the number of data started increasing, the number of data types started increasing, we had a very non-scalable way of structures. Like, we just had to connect things in a much more harder way than in a very seamless way. We had some kind of scripts which could generate data, just convert it to some random thrift format and serialize it and then put it in a HDFS. It was not in a very streamlined way. And next part was the validation. So obviously, when the output was belonging to a different data type, we tried to download it. We had distinct deserializers in the UDFs, and we were using some pick script to convert it to a CSV manner, which was not working for us beyond a point. And the host setup was also manual, so we didn't work on any automation at that point of time. And the regression part was very expensive because of this, because once we started getting some kind of output and once people start making some kind of bug fixes, this semi-automated way was inducing some kind of manual works in between. And because of this, we were not able to scale much and reduce much of the time, and that started becoming a, inducing delays into the time to release. So, and also, like, sometimes once we do the complete functional part, whatever production data or random data, though it is not completely solved as of now for us, at least some 60% of data we were able to run using the random data and the production data. We had to do some manual testing. Say, for example, for a process may consume feed 1, 2, and 3. So we may have to go to the production, find out where this feed 1, 2, 3 is present, and get what are all the data are present manually, and this we need to put, which was a very time consuming part. Well, especially giving credits to the size of the data that we handle daily. So because of all these things, parallelization is not a straightforward one, and so is the end-to-end test or the CA. So how we were able to handle that in a strider way. So we felt that, like, the one of the most important input is just give me the build that I need to test from the Jenkins. The framework would be able to download it. So all this distribution validation would be pretty seamless. And since the system has a generic data type to understand, any input type would be converted to the framework understandable data, and any output type also would be able to be converted. And in the end, the difference, the whatever test we do, is just a JSON diff. And then the host setup started becoming pretty automated, because we were able to make sure that so once it comes to the AWS instance creation, we were able to install stuff automatically through the framework. And the regression, because of all these things are being handled, the regression started becoming very inexpensive. And we were also able to hook it to the tools, some of the other tools that we had developed, which could write some random generator and as well as some production sampler, and do some testing out of it, which did some justice with respect to the testing. And moreover, since we are using a TestNG for developing this, parallelization was not an issue. That is, I can run tests parallelly on a process level, and I can run multiple processes at the same time. This parallelization can be achieved in a different level, so that this basically reduces time from different perspectives. And also this is extensible to create an end-to-end test. As long as I know where the graph basically starts, what is the starting point, and how the pipeline basically goes, if I can understand that order, if I can give that as an input to the system would be able to the system would be extendable enough to run all these things, and it be able to compare and do a final end-to-end testing for that. And because of all these things, it was pretty easy to get it hooked into a Jenkins also. So Karan would be explaining more on how in depth about Strider and what are all the aspects that it covers.
Hello guys. So so I'll take you to the test flow. How is the test flow? How does the test flow look in Strider? So if you want to run a functional regression test, what is the first thing you want? The first thing you want is a environment, right? First thing you need for testing is environment. So so a Strider allows you to either give your own testing machine. You can give its IP, give its host name, and it will contact its services, or it even allows you to spin up your own AWS cluster using their APIs. So it really removes the initial bottleneck of a cluster. Secondly, once you have all your services ready, all your Hadoop services ready, all your Falcon ready, all your Uzi ready, now you want to install the distribution, your user distribution onto that machine. So the artifact deploys your artifacts on the machine on the test machine, right? After that, now you have your machine ready with your user libs deployed, your user jars deployed. After that, you want to create your own data. So Strider allows you to give two kinds of data. One is the data that is sampled from production. So we can pull samples from productions based on the process XML, or we can also create an own custom functional data. So functional data, suppose you want an input timestamp, let's say 123 in your functional data. So your production won't be having that timestamp because that's invalid. So Strider allows you to give that kind of timestamps. How it does it? It uses JSONs. We chose JSONs because they are very human readable and they are very editable. So the tester easily can start making a lot of functional tests in a jiffy, right? So you have your input data ready. Now comes part of now you want to schedule your process. So scheduling parallel scheduling is a little bit tricky, because suppose your process, you want to run two instances of the process at the same time, right? So your both your process will get on, let's say, inputs ABC. So how you determine which instance wants to pick up what kind of data you want to put. So if you put, let's say, the same data on ABC, the two processes will pick up the same data, but you don't want that. You want it to be parallel. You want to execute your test parallelly. So the scheduler takes care of that. Takes it it appends some things, some timestamps to the past, so that it's multiple runs of the same process can happen on the same machine. So that greatly increases our efficiency. Now your process has run. Now you want to validate. So again, for validation, we use JSONs. We convert the data back from HDFS or from HBase or from Aerospike. We convert it back into JSON and then do an assert. This allows us to instantly see the diff, what exactly is the problem with the data, and whether the data is right or not. Yeah. So in this slide, you can see what exactly Strider has done. So if you see the black boxes, these were all, each one of them was a manual step before. You needed to test setup, you needed a test executor, and you needed to validate. But now we have pushed all these things to Strider. So this is the main reason for the efficiency increase. So now you just give, if you see the test ng XML, you give your input data set, your golden data set, your process start time, your process end time, and basically the location of your Jenkins build or your artifact basically. And Strider will run the entire job and do an assert on the golden data set that you created. Right now, I want to make a point that the golden data set is quite handcrafted, because we haven't been able to generate it automatically as of yet. So we basically handcraft the golden data set, and as it's a JSON, it's pretty easy to do so, right? So this is an example of a test.ng XML. As you can, so here we have the process name, the test name, the test description, just for versioning, just for future reference, for start time, the end time, and here you have your own test executor. So suppose you want to run a pipeline. So the pipeline path is, say, process, okay, MR job 1, MR job 2, MR job 3, MR job 4. So if you can write your own test executors, and you can just specify, okay, I want process 1, 2, 3, 4 in my pipeline, and Strider will run it for you and do asserts along the way. So here are the sample JSONs. So while designing Strider, we didn't want to actually handle paths, because remembering paths, say we have a very long path because we have like 5 TBs of data daily. So remembering all the paths becomes a pain. So so the abstraction in Falcon of a path is a feed name. So we use feed name. So basically, from the feed, if you see the header, so there's a feed tag. Feed tag directly tells which path to use. Secondly, what type is it? So it can be a thrift type, it can be a protobuf type, it can be a CSV. So what kind of compression you want? You want a GZ compression, you want a LZO compression. And as you can see on the right side, so that's a thrift. if you want to basically play around with the thrift, you just need to edit the JSON file, and your functional tests are ready. So, these are some metrics. I would like to say that Strider does not decrease the process runtime, but it decreases the process setup time and the process validation time. So, because of that, we are able to achieve the efficiency, this efficiency. So, suppose a new change comes in the process logic. We just have to, if the process logic changes, so there's some optimization in the process, your golden data set won't change. So your regression, it's done in a jiffy. You can have a tea break, just run the regression, have a tea break, and by the time you come back, it's done. So it saves a lot of QM man hours. Now the validation is quite the automated, and prod sampling. So like in InMobi, we have so much of data. So uh, a typical process may end up consuming like 9 inputs. If you want to manually copy 9 inputs from production, first figure out the feed name, then figure out the feed path, and then go to production, copy one part file. Maybe the part file is very big, and then you chop the part file. All of this takes time. With Strider, we have automatically handled this in our framework. Okay. So extensible. So Strider is quite extensible. We are using TestNG, so you can have your own custom classes. You can have your own custom executors, however you want to run. You can have your own validators. You will be having different inputs and outputs, and so you can create your own input and output converters. Right now, like, we have handled thrift in such a way that we don't write any custom code for any kind of thrift. We don't write any custom code for any kind of protobuf. So we have wrote that kind of generic code, so anybody can write it basically. So it's quite extensible. So what is the roadmap of Strider? So we are yet to solve the data generation completely. We I'll say we are about 60% complete. We have to figure out how we can figure out the join chains in like automatically. We'll just say, okay, because any job will have joins, and you want a non-zero output if you are randomly generating data. So we want to have we want to invest some time in data generation. Now we also want to do some performance testing out of it, because as we have automated the cluster deployment, we want to play around with cluster configs, and when we have the data generation ready, we can basically stress test the job, see what are the map millis, what are the reduced millis, and benchmark it across various cluster configs. So we can do a little bit of performance testing. Thirdly, we want to actually go away with the golden data set approach. What we think is that the tester should write his own version of his pipeline, right? So because he does not have to worry about scale, he does not has to worry about the scheduling entities, he does not has to worry about the distribution. He doesn't have to code for that. So if we want the tester to make his own pipeline, so if a product ask comes, two guys work on it. The tester should take like 2 hours, if the dev takes like 10 hours, and then we can do an assert. So we want to head there. So this is the roadmap of Strider. So this is basically a summary. Strider is a test automation framework built on Falcon APIs, Uzi, and Hadoop. It allows you to do sanity, regression, and functional testing. The bootstrapping has been made very easy, so can start testing in a jiffy. We use a standard data type. We use a JSON data type, and that is a standard for us. We basically convert from JSON and to JSON, whatever data type we want to use. It's very easy to create a test, and it's quite extensible. Thank you. Any questions? Yep. Yep. Anyone? Yep.
So, are you going to open source this code? And then the second question is, when you said the automatic provisioning part, you specifically mention EC2.
Yeah.
Have you worked on the Google estate or
No,
not?
no. We use Apache. We use Where APIs. We use Where APIs for cluster provisioning.
Yes,
right?
but what
Yeah.
I'm asking, have you actually played with some of the Google GCs or only with Amazon ones?
We played around with it and it worked for us. So we didn't invest further time in it. About open sourcing, yes, we are just cleaning up some code, and we may think to open source this if it adds value to the community. Yep, yep.
So one question. So which kind of jobs or which kind of pipelines can you actually test with Stride? Can you test only Falcon pipelines or also plain Uzi or some Hive only jobs, or what things can you test actually with it?
So what do you mean by an Uzi pipeline?
So can you test some kind of Uzi job, for example, with your system? If you have
So-
just one simple Uzi workflow, can you test it with your system?
Yeah,
Or,
yeah.
or,
So no, so
or can you test only Falcon pipelines?
only Falcon as of yet. So yeah, and so Uzi internally will be MR, Pig, Hive, whatever the action you want to specify in the workflow. So it takes care of a lot of varieties. The scheduler is actually Uzi.
So yeah, right now it works only on top of Falcon API. That's a basic requirement for it right now.
Yep.
So are all these tests running on separate Hadoop test clusters, or they can also run on like a dev machine? Like you bring up like the environment and you can actually test it locally.
So right now they run on one machine, or they run on one machine, or you can actually even specify multiple machines. So
Oh, so
you
they're
can
not
specify any machine.
So they're not actually bringing up any like Hadoop clusters to actually
No,
run
they-
the jobs.
So the cluster provisioner takes care of that.
Okay. So okay.
So the system entry points take care of that.
Got it.
And if you specify your own, we assume it to be running.
Okay. And so like going back to the open source question, like what if your data pipelines are not built out of Falcon, like how easy it is for like someone else to be able to integrate it? Like I know like you don't support it, but like is it extensible to support other kinds of data pipelines?
So if you see how Stride is built, you basically need to change only the test scheduler part.
Okay.
That's a module itself. So if you change that, you can use your own scheduler.
So you can plug in
Yeah,
a different
yeah, yep,
scheduler. Okay.
yep.
Thank you.
Instead of adding an implementation for Falcon, we can have an implementation, test implementation, scheduling implementation for Uzi or something else. So that is the only time-consuming part that you will face.
Okay. Thank you.
Any more
Any other
questions?
question? Thank you.
Thank you.